Welcome back to Math 104. What is the probability that a randomly selected adult woman in the US has a height greater than 66.4 inches? We figured out earlier that since mu equals 63.7 inches and the standard deviation equals 2.7 inches, 66.4 inches equals mu plus 1 copy of sigma. The event we're describing, that a randomly selected adult woman has a height greater than 66.4 inches, therefore corresponds to this region underneath the bell curve. Now notice that this region actually extends a little bit beyond what appears in the diagram. If this curve had been continued beyond the 3 standard deviation mark, there would be some territory in here, and that is included in this event. There are people whose height is more than 3 standard deviations above the mean. So we do have to be a little bit careful here when we describe an event like this, that's defined by all outcomes greater than a certain outcome, all heights greater than a certain height. To find this probability, let's first notice that the probability of having a height greater than the mean equals 0.5. In this context, we're not going to distinguish between greater than the mean or greater than or equal to the mean. We're just going to think in terms of half the data being above mu and half the data being below mu. So if there's a 0.5 probability of being to the right of mu, that means that 0.5 minus this particular 0.3413, which equals 0.1587, is the probability that we're looking for. If this entire region to the right of mu has probability 0.5, and this chunk of it that we're not counting, that's not shaded in blue, accounts for 0.3413, then whatever is left out of 0.5, namely 0.1587, must be counting up the probability of everything shaded in blue here, which is exactly our event of having a height greater than 66.4 inches, greater than 1 standard deviation above the mean. So the probability here equals 0.1587. It's worth remarking that this extra little bit of territory beyond 3 standard deviations above the mean actually has such a small probability that if you just added up this 0.1359 and this 0.0228, you would have gotten the same thing. You would have gotten 0.1587. Whatever these extremely tall people contribute to the probability we're computing, it actually disappears in the round-off error. Now suppose you know that a certain adult woman in the US is at least 61 inches tall, but you know nothing else about her. This means that we have certain given information. What is the probability that she is between 61 inches and 63.7 inches tall? The fact that we already know that she is at least 61 inches tall means that we are not randomly selecting someone from the entire population, but just from a certain subset of the population, consisting of those whose height is at least mu minus 1 copy of sigma. So everyone from mu minus 1 copy of sigma up is the subpopulation that we are randomly selecting from. The event that we're interested in is the event that she falls within this range between mu minus 1 copy of sigma and mu itself. To sort this out, it's helpful to define 2 events here. Let's define the event A, that she is at least 61 inches tall. That means that we're computing a probability conditional on A. And then B will be the event that she is between 61 inches and 63.7 inches tall. We need to compute the probability of B given A. When in doubt, go back to the definition of conditional probability. This is the probability of B intersect A, the event that she is between 61 inches and 63.7 inches in height, and that she is at least 61 inches in height, divided by the probability of A. But notice that the probability of B intersect A, the unconditional probability that both of these occur, is just the same thing as the probability of B itself. This equals 0.3413, right? That's the unconditional probability of B that corresponds to this shaded region in blue here in the diagram. So 0.3413 is the unconditional probability that a randomly selected woman would have a height between mu minus 1 sigma and mu. We divide that by the probability of A, the unconditional probability of being at least 61 inches in height, that is, having a height that falls somewhere above mu minus 1 sigma. Well, how much is the probability of A? You can think of it this way. Everything to the right of mu has probability 0.5, Everything in this blue shaded region has probability 0.3413. Overall, A has a probability of 0.8413. Just the sum of this 0.3413 and this 0.5. This turns out to be approximately 0.4057. By recalling what we know about conditional probability and putting it together with this new information about the empirical rule, we are able to answer this kind of conditional probability question. We will take a closer look at normal distributions in the next video set. And that is all for video set number 9.